Greetings, mathematicians. This is Mrs. Mounts, and today we are going to work on simplifying algebraic expressions. So here are the Laffy Taffy jokes. All right, that last one's a little mathy there. All right, let me get my screen set up here. And there we go. All right, so you are going to be, I think, in that first page of your packet. And let me zoom in here a little bit. Now remember, you can make your video bigger. You can always pause. I kind of have a big definition here that we're going to be taking a look at. So this is simplify an algebraic expression. And so what is the definition of an algebraic expression? Okay, so this is a long definition, so feel free to pause it. I'm just going to read it. It's probably going to take you more time to write it out, but it's a symbol or a combination of symbols used in algebra containing one or more numbers, variables, and arithmetic operations. Now, arithmetic operations means add or subtract. Now, when we're simplifying, we may have to do some multiplying, but that's how you separate terms in an expression, is by plus signs and minus signs. Now we're going to use the substitution property today. We're going to be substituting some values in. And so the substitution properties, you probably have used it in the past, but basically it just means that if A equals B, then B can be replaced with A and vice versa. So we're going to have variables. They're going to say, hey, like A equals 3 and B equals -3. We're going to replace those values in for the variables, and then we're going to solve it. To evaluate an expression with variable replacements, we are going to substitute the variables with their given values. This is so important. Each time you substitute a variable with a number, we have to put parentheses around it. So it's just a habit you have to get into so that you get the correct answer. We're only going to have one correct answer today. And then you can probably guess it, and maybe you can kind of see it through the paper. We are definitely going to follow the order of operations. PEMDAS means parentheses, exponents. We're going to multiply and divide from left to right. We're going to add and subtract from left to right. And again, I know you've been working on order of operations probably since 6th grade, but these are going to be some advanced problems here. We're going to be substituting in some negatives. We're going to have some exponents. And so they should be a higher challenge type of problem than you've seen before, and that's good. We're trying to expand your knowledge here. I'm going to go over 3 examples with you. So let me zoom in. I'm going to go over example 1. All right, so we can see it really good there. So I am going to substitute 2 in for A, 4 in for B, and 7 in for C. So let's get at it. So A is 2. Parentheses around it, okay? So for the B, I am going to put in the value of 4. So you have parentheses around the B. The exponent goes on the outside. So variables have parentheses around them. Okay, so it's not like this, it's just around the B. Okay, so that's really important as you substitute in. Plus 7 will be substituted in for C. Now we follow order of operations. So we do have parentheses, okay, I get that, but we also have an exponent that we have to take care of. Okay, so we'll do that first. 4 times 4, and you got to get in your your head, we're doing exponents, so it's the number times itself. 4 times 4 is 16. Still going to keep those parentheses. So I just did one part of the simplifying so far. Okay, now we look from left to right. I have multiplication, so I'm going to take care of that next. 2 times 16 is 32. And now I can finally get my answer. We're down to just one step here. So 39 would be the value for this particular expression. So what we did is we simplified. Okay, so anytime you see a problem like this, it's not going to say solve, it's going to say simplify. Solving is when we have an equal sign, and then we have to, end up simplifying both sides with their like terms. So we'll get to that. We will definitely get to that, but these are all simplified today. No equal signs. All right, number 2. All right, this time we're going to substitute -2 in for x. I write the 3, then I automatically put a parentheses. I'm going to put -2 in there. Variables have parentheses. The exponent 2 goes on the outside, -4, parenthesis for that x, and I put in -2. All right, so PEMDAS. And I get it, we have a lot of parentheses, but usually we kind of just skip to that exponent part. So let's go, we'll do that next. -2 times -2. So a negative times a negative is a positive. So I'm going to put +4 just right underneath. Minus, I can go ahead and simplify this. This is indicating 4 times -2, which is -8. From left to right, 3 times 4 is 12. And when we subtract the opposite, that becomes plus, and you probably remember that. So when you subtract an opposite, it becomes plus. We add 8, and our final answer there would be 20. So it's just a step-by-step process, and the expectation is that you show all the work. These are pretty difficult to do in your head. Okay, one last example I want to go over on the back side is number 11. Okay, so I'm going to go over 11. You can see we have an absolute value in there, so I just wanted to review that with you. All right, let's go ahead and substitute in. Now we have this negative that stays on the outside. Remember, the parentheses are around the variable. Okay, a is -2, squared on the outside. So this step is probably the most important step, is that you get everything substituted in correctly and you get those parentheses in place. -2, parenthesis for b, 3, parenthesis for c, -3, minus, and then c is -3. Okay, that's a lot of parentheses going on there. Okay, so we just break it down step by step. We're going to start with the exponent. We have an exponent here. -2 times -2 is +4. Keep it in parentheses. Negative is on the outside. Okay, so now I'm going to go here. We have multiplication, lots of multiplication. We have 2 times 3 times -3. Okay, so 2 times 3 is 6, times -3 is -18. Again, keep that in parentheses. Absolute value just means how far is -3 away from 0? Well, -3 is 3 away from 0. So I get rid of those absolute value signs. -3 is 3 away from 0, but we're subtracting that value. Okay, so that's why I just brought down that subtraction sign. Okay, let's do some more simplifying. This is the opposite of 4, which is -4. This is the opposite of -8, which is 18, which is +18, -3. Now, I like to get my negatives. I like to get those together. So it's 18 plus negative 7. And when I simplify that, I can see I have way more positive than I do negative. 18 is further away from 0. So I take away 7 from 18. I'm left with positive 11. All right, so we're going to do some group work with these problems, okay? So again, hopefully we'll do some more practice. And again, these are some pretty advanced order of operation and substitution problems, okay? But we can do it. It's just a step-by-step process.